We are looking here at solving systems of equations using the elimination method. This is part 2. So if you haven't seen my video for part 1, or if you're not good with our first piece of this lesson, you might want to go back and look at that. Because in our first lesson, we saw how we could take two linear equations that neither were solved for a variable, and we could add those two equations together by lining up the equal signs. And when we did that, one of our terms would eliminate because they were the exact opposite. In our second example, we saw sometimes we needed to multiply by a -1 to make that happen. In this video, you're going to see sometimes we need to multiply one of the equations by a number other than -1 to get it to where we need it to be to eliminate. And sometimes we need to multiply both equations. So let's take a look. In this case here, if I look at these two equations, and I'm going to start off here in red. This is something I would not recommend writing down, but just watching. If I added these two equations right now, I would get 5x, because 2x plus 3x is 5x. Y plus -2y gives me -1y, and 10 plus 1 equals 11. That means when I added them, none of my variables eliminated. That's a problem. I need my variables to eliminate in order for this to be the elimination method. So I need to look at what I can do before I add them together in order for them to eliminate. For that to happen, one of my variables must be the exact opposite. I look at my variables here. I see that I've got a 2x and a 3x. I see that those, I can't really multiply 2 by something to get to -3. I can't multiply 3 by something to get to -2. It'd be hard to make those the opposite. However, y and -2y. If I were to change my y so that it was a 2y, well then +2 and -2 would be the opposite. That's what I'm looking for. So when I look at this, I'm going to go ahead and start by looking at multiplying this top equation by times +2. All right? When I multiply that by +2, we'll see what happens. Let me go ahead and do that. I'll pull it over here. My top one, 2 times 2x becomes 4x. I have to multiply 2 times everything. 2 times y becomes 2y, and 2 times 10 becomes 20. That's where most people mess up. They forget to do that other side of the equation there. My bottom equation, I'm not changing. 3x stays the same, -2y stays the same, and equals 1 stays the same. But notice what we have now. When I line these up, my +2y and -2y are exact opposites, and they will cancel each other out. In other words, eliminate, hence the elimination method. And I'll add what's left over. 4x plus 3x, because I'm adding those, gives me 7x altogether, equals, on the other side, 20 plus 1 is 21. And I can divide by 7 in order to solve for x, getting 3. So that's where this one's different. Once we do that, what we do here is the same that we've always done. We take it and we plug it back into my original equation. So I'll say 3 times 3 minus 2y equals 1, and I'll solve that for y, giving me 9, 2y equals 1, subtract my 9, make 2y equals -8, that's a -8, by the way, and divide by -2 on both sides. I find that y equals 4. So now I know that x is 3, y is 4. I'm still going to check it to make sure that it's right. My check step will always use my other equation. So I'm using the 2x plus y here. So 2 times x plus y equals 10. And 6 plus 4, well, that is indeed 10. So it works. That means my answer is correct. 3 is my x, comma, 4 is my y. Put it in parentheses because it's an ordered pair. And we've got our intersection point. Let's take a look at another example. All right, this one now. Take a moment to look at it. Is there anything that I can do to make my terms the exact opposite? Can I multiply 4 by anything to get 9? Well, not a whole number. All right, I need those to be opposite, so I would need it to be -9. All right, what about this here? Oh, these are, I've noticed here I've got a positive and a negative already on my y. That's nice, okay? But what times 3 would make it 4? That's a little bit harder. I can't necessarily think of a good number. This is a situation where we can still use the elimination method. However, I'm going to have to multiply both of my equations by 2 different numbers. And I'm allowed to do that. The multiplicative property of the multiplication property of equality shows me that I'm allowed to multiply my top equation by any number I want and my bottom equation by any number I want, as long as I do it all the way across. I'm going to think of this like getting a common denominator. I'm going to choose to eliminate my y's here because they're already a positive and a negative. So what's the first number that 3 and 4 both go into? Well, that's 12. So I could multiply the top equation by 4 because 3 times 4 would get me 12. And I could multiply my bottom equation by 3 because 4 times 3 is again 12. Watch what happens. When I multiply by 4, you've got to do everything. So 16x, because 4 times 4x is 16x, plus 12y equals, don't forget that 10. 4 times 10 is 40. On the bottom, 3 times 9 is going to give me 27x, and 3 times negative 4 is going to give me negative 12y, and 3 times 1 is going to give me 3. And that's exactly why I did it. Take a look right here. That is what I was looking for. I chose 4 on top and 3 on the bottom so that my y terms became positive 12 and negative 12 because they will cancel each other out. That's what we're looking for. So if I go ahead and I now add these together and put my line down, make sure my equal sign is lined up, these are going to cancel out. They're going to eliminate. All right, 16x plus 27x. Well, if I add those together, I get 43x. And on the other side, I get 40 plus 3, which is 43. And I can do my division to find out that x is equal to 1. All right. Once again, once I have x, go back, plug it in. I'll just use this bottom equation here. It's nice and simple to use. So I'll say 9 times 1 minus 4y equals 1. And I'll solve that for y. And I find that y is 2. Once again, once I've got both my x and y, check it in the other equation. Do not use the same equation to find y and to check. You want to use both equations. So I'm going to use the 4 times x plus 3 times y. And I'm going to double check, is that 10? Well, I get 4 plus 6 again, ironically. And I find that 10 is equal to 10. So that means my answer's right. Always written in an ordered pair, x, comma, y. In parentheses to say that one is x, one is y, and that is my intersection point between these two lines.